Welcome to another GCBASIC demonstration. It's actually a demonstration, it's actually sort of showcasing the ADL power monitoring solution that I've been working on. So ADL is shown there. It's a little, I'll tell you what it is in a minute because there's a couple of things I've got to say beforehand. Okay, right, caveat. This is dangerous, what I'm doing. This equipment uses power lines and there's a high risk of electrical shock. So if you're going to do this, take care of danger. Work with a qualified engineer to ensure you are safe. And do not replicate my bench setup. Use a proper housing for the equipment and do it properly. I am showing you my setup. Electrical safety, ensure proper insulation when connecting the ADL200 to power lines. Ensure that everything operates within the correct voltages, especially the microcontrollers and GLCDs that we'll be looking at. Ensure that you understand what's called Modbus. I'll come into that later, but if you get that wrong, then you'll get display errors and communication failures. And always test everything in a controlled environment to avoid equipment damage. Those two slides, that is the previous slide, caveat and safety, should be read in some detail before proceeding. So what am I talking about? I'm talking about an ADL 200. What it is, the project is actually to read and display power metrics, voltage, current, and frequency. And I'm going to show you that using an 18 mega microcontroller. It's a bit like an Arduino. It could be anything. And it's written in GCBASIC. I'm going to show you all this very shortly. So what sort of things can we have a look at? We can see power, we can see active energy, peak, flat energy, valleys, code, voltages, frequencies, currents, etc. There's a whole series of parameters that you can pull out from this very sophisticated device. So this device, let's have a look at what it looks like on the bench, okay? I mean, you get a really good idea. So this is what it is. It's one of these. There's another one in the box here. ADL200 fits in a DIN rail inside of your electrical cabinet, and you can sort of use this user interface here to see the power, etc., and all these parameters. But this doesn't show you an awful lot, and it's pretty difficult to navigate. So what we're going to do is we're going to hook it up to one of these. It's a microcontroller, and we're going to use a sort of TTL thing to convert the power and put all the data on a GLCD. And so we're going to do that in a few moments. But what we're going to do is take those simple components. I'm going to put it back in its box, and we're going to slide across some tech in a minute and have a look. Great. Back to the slides. So what you've got, I've just shown you an ADL200. You've got a user interface, and you can look through some of the parameters, and it's not all documented. I documented it because I was working on this project. It's not well documented, but you know what? It works quite well. So the hardware component is the ADL200 energy meter. It tracks power metrics. You saw I'm going to put it on a GLCD, and we're going to use a core microcontroller for the processing, and it's going to pull the data out and display it for us. I've selected 3 metrics to show on the GLCD. We can format these metrics into decimal places, and it's continuous monitoring on a dashboard. So you could change the output device from a GLCD to Wi-Fi, to a disk or a memory device if you wanted to do long-term tracking. But we're going to just see it on a GLCD as a method of showing things. So what we're going to do is put it on that GLCD, but what in the background we're going to see is what's called Modbus. It's a protocol for communication over serial, and we're going to see that being masked because there's a routine and you literally just call it. There's a ring buffer inside the microcontroller so no data is lost. And there's a sophisticated state engine for efficient data management. So you don't lose any data, you make a request and over this Modbus protocol, and you get a response. Included in the library is a lot of software debugging, so you can actually hook this up and debug what you're doing, because as you change it and develop it and add in other devices like memory, Wi-Fi, etc., you'll need a little bit of debug. So I've left all that in a very sophisticated manner, and it really does simplify troubleshooting and development. And it's very sophisticated debugging, but it's turned off by normal, and it doesn't interfere with operation. So there are some key files. They're up on GitHub. You can have a look. I'll show you those in a moment. I developed a specific header for this device, the ADL200. There may be others I put in later on. And there's a Modbus. So it's a standard library that can be reused. And I've given you extensive setup guides and so on how to add new values, etc. So let's have a quick look out on GitHub. There's my desktop. That's GitHub here, is it? No, that's not GitHub, is it? That's my, here's GitHub here. I'll pull that across. There we go. I'll just maximize that so we can see it. There we go. So this is GitHub. I'll zoom in for you so you can actually see it. There is a whole series of pages here on the power monitoring device, all its key features and etc. So it's just a highlight. There's a couple of key folders. There's all the GCBASIC one. There's a resource folder with improved documentation, or the PDFs I got from the manufacturer. They actually did work with me to make this all work. And there's undocumented information that I put up there as well. There's some images, which is quite useful. And then there's the GCBASIC folder, which has got the core components. And essentially, it's got one major program, which we won't be looking at that in detail, but I've given you a series of READMEs and how to get started and how to add new values. And that's all documented in an extensive README inside of the GitHub, and that's a really good place to have it put, because then we can actually you can actually play with that in your own time. So I've documented every file that's been up there, so you get a really good idea on how to do it. And there's a complete walkthrough, as I just said, on how to use add in new values. Let's have a quick look at that. Number 3, add new values. It's a complete document on how to walk through and add your own values. What we're going to see is 3 values, which is frequency, voltage, and the current. So up on GitHub, it's sitting there. So obviously, to get started on this, you're going to have to put GCBASIC up there, connect the ADL and the GLCD, upload the program, and just get started. It's as simple as that. It's very, very simple. You shouldn't be too concerned about it. But once you've done that, you can extend the project, you can add your own values, and I've given you, as I said, that guide to add new metrics, and then you can adjust things in the GLCD or extend it into other components. So what are we looking at? We're looking at a very simple architecture. We've got a microcontroller. We saw that earlier on. We have a little adapter called a TTL RS485 adapter, a couple of dollars off of eBay, and the ADL200 itself. I'm going to have a drink of coffee. Now, what actually happens is the microcontroller makes requests, and inside the microcontroller there's a library, and that library formats it up into this protocol called Modbus RTU, and then it responds back, the ADL does, with the data. So, and that is what is happening. There's a library, you make a request for an address, it returns that value, and its syntax checks it and gets the raw value out, which you can then put on the screen. The TTL adapter in the middle is just doing a conversion between the RS232 TTL values coming out of the USART on the microcontroller and put them in the correct format for RS485, which is on the A and B line, and that's what you connect it to. So it's relatively simple. The A and B lines are very clearly annotated in the documentation. Let's have a look at what we've got here. Okay, we're going to pull it in and have a real look at the desk. little mouthful of coffee. Okay, I have got power. Well, I'm using this power. It's just a 5-volt supply, just to show you that you don't have to have it hooked up to the computer. What have I got? I've got, it's all turned off. It's all turned off. I've got a board. Here we go, look, I've got a board. I've got a microcontroller. I have got a, what's that called? A voltage leveler. That's because I want to make sure that my GLCD only gets 3-volt signals. This is very specific to this GLCD. So look, all I've got in reality is the serial connection on the microcontroller going out to this device here, which is the RS. Let me just rotate that. This is the RS. What's it called on the back? MCU TTL RS485, and it's got a ground and 5 volts going into it, nothing at the moment. And it's got these 2 wires coming out into here. And here is, as I said, don't do what I'm doing. Here is the device. It's the ADL200. And I can sort of cursor through this, and the voltage is currently 238. 238. Let me just try and get that. 238. Frequency of no amperage. 49.9. You can see that there. That's the address of the device, baud rate. And that's all you can see actually through this user interface. That's it, 238. So that is attached and it's on the floor. It's sitting there safely. And attached to that is a load. I've got electricity coming in and I've got electricity coming out. Now, I've not really thought about doing that. Let me just spin that up. Can I get this in the camera at the same time? I doubt I can. No, I can't. That's a blow. Oh, it's a bit washed out. What I'm trying to do is just trying to get these two side by side, but this keeps turning because it's got a lot of cable on it. Let me try and stabilize that for us. No, it might work. There you go. Oh, computers, don't work me. That's not what I want to show you. I'm going to read that thing. All right. USB. I'm just going to put that into the power. How do I do that? I haven't done this before. It's drawing a couple of milliamps. There you go, 5 milliamps. There we go. So what we've got is a display. It just came up live. 230. It says on it 238, which is probably true because we're just having a look at that. Amperage is 0.1. It's got a little bit of drain on it. Oh, of course it has, because what's attached to it has got a drain on it. And I'll just show you. The interface on the GLCD is quite simple. If I just reset it, just reset the microcontroller, just updates things. This is all done from software. This is the voltage. It's just synchronizing up. The red light is, there you go, it's gone green now. 236.7, 0.1 amps, and 49.93 as a frequency. And over here, you've got some other active metrics. Now, you could fill this with active metrics. It's down to you. I've just done this for what I need. So this is live. So when this flashes, it's live, and we could then look at that device to see it working. Why don't I put some load on that? So what I'm going to do, I'm just going to toggle out. This is toggling out to my Home Assistant. Now, hopefully you can see my Home Assistant. If you don't know what Home Assistant is, I'm not doing a crash course on Home Assistant. Home Assistant is it controls my house, okay? And I'm going to turn on a bit of load. I'm going to turn on the dehumidifier, and then I'm going to go back to the camera. We've now got 1 amp on it, and if I turn it off, the dehumidifier, it's just gone off. We go back to, and that is the transient amperage used. I didn't know that, by a Wiser home electric sensor. I didn't know that. That's interesting. So dehumidifier on, and we can see the amperage. 5 amps. That would make sense. It's a dehumidifier. It's pulling a lot of amps. Okay. Yeah, that makes a lot of amps. And currently it's 231 0.4, and I could go to the device over here and I could see that. Let's try and pull that in. Now here it is, it's sort of working away. Now, and it's flashing. You can just see it flashing here on the LED. There's a little LED. That's a read operation by the microcontroller, or is it a pulse? I think it's a pulse every unit. 2.3. There we go. Let's see if we can see this all at the same time. 2.365, 2.357. It doesn't. What's the word? It doesn't bang away. It takes. I've timed it so it doesn't actually hammer away. So what we've got is a really simple way of sending signals from a microcontroller, which we saw, onto a GLCD. And a GLCD could be really whatever you want it to be. I'm going to turn off the dehumidifier. Turned it off behind me. I'm going to unplug that just to see if it actually just dropped to 0. Unplugged it. There you go. It is, so it's drawing 0.01 amps, just a transient sitting there. But that's the cost, I guess, of automation in your house. 2.36. I'm based in the UK. That makes absolute sense. The code itself is self-explanatory and fully documented. I have spent hours documenting this program. So I am not going to go into that today. So summary, what have we got? We've got real-time energy monitoring dashboard. You've got Modbus RTU, GLCDs, and all the debug. You can set up your own hardware, compile the code, and monitor power on the ADL200 or any other Modbus device. It's a very simple library. Enjoy.